Hello, everyone. I'm a little nervous, but I'm glad everyone's here. We're going to do some math together today. And I'm so thrilled to have everyone with you. I'm a hand gesture and I talk fast, so if I'm going too fast, let me know. We're moving right along here. My name is Leah Dix-White, and I'm a regional consultant with KCM. And I'm so thrilled to meet with you guys today for this brief 30 minutes. All right, so what do we do at KCM? We are all about supporting teachers. We offer professional learning for teachers. We have a wonderful annual conference where we get together. We are very fluent throughout our state in ensuring that mathematics is relevant and that all teachers have the resources they need to successfully instruct from pre-K to post-secondary. So that's some information about KCM. You can visit our website. The information is there. If you want additional resources to find out other professional learning opportunities we'll have available moving forward. So let's get with today's agenda. We're going to start off looking at some research and then touching base with our Kentucky academic standards. And then we're going to dive right in and do some math. We're going to look at exponential growth in context of this COVID-19 pandemic. And then we'll do a little math together. We'll have 3 tasks, and all 3 tasks kind of refer back to an article that I stumbled upon, which I'll talk about in a minute. We'll also look at a brief video about how exponential growth looks and some simulations comparing that to linear growth. And then I have some extension exercises if you're interested, some references, and then we have some virtual manipulatives as well. All right, so if at any time you want to jump in, just jump into the chat. And also this is interactive, guys, so participate. Let's get going. Let's talk about the research. So the research of this session is grounded in, you got it, principles to action from NCTM. Particularly, we're going to be looking at those effective mathematics teaching practices, particularly number 2, in promoting reasoning and problem solving for our students. So we're going to do a rich task together. Another important thing is that we are now in this digital era, and so we have to, as instructors and educators, think of ways to digitally contextualize, grade align academic instruction, that's relevant for our kids. And so I'm hoping that through this presentation, you'll get some ideas that will help you make a context for your students in a digital way. We'll focus on the content in that matter, and we'll try to bring it all together and have some rich conversation. So let's look at the standards. The standards that we're going to look at today in this session have to do with exponential functions. So we're going to be interpreting the parameters of exponential functions, particularly the rate parameter. And so the idea is to have students to get a rich conceptual understanding of what that growth rate means. I've also listed the student mathematical practices, make sense and persevere, and also to reason abstractly and quantitatively. So those are some things that are kind of fuel the math. Also, we're going to be graphing and looking particularly at exponential functions and decimals. So I hope you guys are ready to do some math. So if you look at, I've tried to put the goals together in one statement. We're going to look at 3 representations of the C19th growth. We're going to look at those parameters, particularly the rate. And then we're going to see if there's some models we can create in context to go with that. And then we're going to go back and forth between these representations in Desmos and in other forms as well. So are you ready? Let's set up this context really quick. All right, so this session was kind of stemmed from a New York Times article that I read. I think it was on the 13th of March. And what's interesting about this article, there was so much math in it. I was like, oh my gosh, it blows me away. There's so much math. So that's why I'm sharing it with you today. So The individual in the slide that you see, her name is Britta Jewell. She's an infectious disease specialist from London. And she began to look at this data and was thinking, oh no, this was back in January. And so this clip that you're seeing here is from this article. The article is called The Exponential Power of Now. And it talks about how Britta was looking at this data that she saw from a tweet from a colleague from New York Times. And it was showing the growth rates in the United States. And she kind of was like, this is crazy. So she called her dad, and her dad's also in the same field. And they were talking, they were like, how are we going to convey to people how serious this is, that this growth is going to affect the lives that we live, and that we're going to have to make some changes. And so the tasks that I've designed around exponential functions are grounded in this article. And so I'm sharing it with you, giving you this context so that when we dive into the task, you're kind of familiar with what I'm referring to in this situation. So this is where we are now. We are social distancing because of these math ideas that Britta Jewell and her father were talking about together, and so many others have noticed as well. And so it's from these conversations about math that we are in this social distancing situation now. So let's get some context for our students. So we're all educators here. So let's put on an educator hat. Let's think about, how are we going to convey to our students digitally this growth that we're talking about? And so what's really interesting, I Googled this and I ran across a really good video that does this, and I'm gonna share it with you guys. And the professor in the video, his name is Matt Yedlin. He's an associate professor from the Department of Electrical and Computer Engineering and faculty in Canada. And so he gave me permission to share this video with you guys. It's a brief simulation of linear and exponential growth. And so when we're thinking about digitally, how do we give our kids context? We have to give our kids some type of semi-concrete models to see, to develop this conceptual understanding. So we're gonna start with this video. And it's very brief, it's about 3 minutes, but I'm gonna share it with you guys and be prepared to talk about it briefly afterwards. So here we go.
Well, here we are again. We're going to do an experiment to illustrate the difference between linear growth and exponential growth. We're going to do a tapping exercise. It's going to be initiated by Amid. Amid's going to tap Peter on Peter's right shoulder, and then he will stand up. Then Peter will pass the tap down the row, and we'll see how long it takes for the tap to swing all the way through the rows, ending with Grant. I'll count 3, 2, 1. Grant's going to time. You'll be the point man. 3, 2, 1, go. How much time, Grant?
19 seconds.
Great. Sit down, everybody. Okay, we're going to try it now differently to illustrate exponential growth. This time, Amid's going to tap Peter's desktop and Wilson's desktop behind Amid and stand up. And then when you get your desktop tapped, you tap 2 desktops and stand up. Grant's going to time. Are we ready? 3, 2, 1, go. How long?
6 seconds.
All right. Now we're going to do it again. This time we're going to initiate it from the center. So Sebastian, you're going to be the person who leads off. Camera ready? 3, 2, 1, go. Grant, how long?
3 seconds.
All right. Question for you. What happened in the first case in terms of people standing up? What happened? Yeah.
The rate of people standing up was constant.
The rate of people standing up was constant. It was about a half a second per person standing up, roughly. Now, we then did 2 taps. So 2, 4, 8, 16, 32, 64. 6 generations of tapping. At a half a second a tap, 6 times a half is 3. So we see the exponential growth effect. And that's what we see when there's a virus spreading. You can see, for example, if Sebastian was infected, this is a crude model of a virus, pass it on to the 2 neighbors and the 4 neighbors and the 8 neighbors. So it's a model for the spreading of a plague, an epidemic. And it's also a model, as we saw earlier, for a chain reaction and fission. Thanks all for participating.
Nice. So, I just want you guys to know that that video is like from 2014. So I don't want you to think anybody was contracting the virus by making that video. But nevertheless, what are you guys thinking about it? What inferences do you have that you would like to share out with the group about that corner and center growth? Anyone?
Hi, Leah. It's Liz.
Hey, Liz.
How are you?
I'm great. How are you? Thanks for joining.
Thanks for having me. I was just thinking about a lot of as you can hear them in the back, I'm at home with my own couple of kids. And even though we are extremely fortunate that we have a comfortable place to hang out and, you know, mommy and daddy can both still get paid from home, you know, it's been tough. The social distancing is really hard. And what I really appreciated about that video is what a perfect visual that was of why social distancing is so important. So that makes it so relevant for now that I hadn't even thought about that, about the corner versus the center. Like, that is such a great application. It's so relevant to the way we're all living right now. And I just really thought that was great.
Great. Thanks for sharing, Liz.
Tell Daddy. Sorry. Okay.
Go ahead, Liz.
Oh, no, I'm sorry. Now I'm muted.
So I was going to say I had that same, Leah, I had that same reaction when I thought from the center, been embedded in this kind of math for a really long time. And I always think about it from one to the other, but then I forgot about this around me, you know, how circular it can be and how, wow. So when you showed that, I was like, oh, wow, that is
All right, guys. Anybody else want to share anything? Okay, well, now's the time to get out your pencils. We're going to do some math. If you have your pencil, all you need is your pencil, paper, or if you want to do it in your head digitally, that's fine too, but I wanted to get you ready for what's coming up next. So I have 3 tasks that I have written in lieu of this article about what we are experiencing now. And what's great about the article is that she made these inferences with her dad is if we could, what can we do to stop this? And so the questions are kind of setting the situation up so that students can explain what the parameters are in the function and really understand this growth. And so take a moment now. You can pick one of the 2 tasks and take a moment and think about how you would respond to the questions, what representation you would write or how you would answer it, and what your students would say also. And I'll give you some time to do that, and I'll do it along with you as well, because it's only fun if we're doing math together. And so I'm going to pick one of those tasks, and then we'll talk about it in just a second. So take a moment, and I'll be quiet if I can. Hope you guys are working. I'm working.
I'm working, but I need my graphing calculator.
Okay, does anybody have anything they would like to share as far as what their students would write, or what a graph would look like, or a representation in response to either task? I'll give you a chance. If you wanted to hold up what you have, that's fine too. Let's see what we got. Right, so what I'm seeing from the feed is a lot of kids are calculator dependent. So what do we do in this matter? Aha, I've got a solution to that. Okay, so wonder and notice would be great too. So I saw that in the comments as well. So let's tackle this, and I'm just gonna share some responses with you. And by the way, I was kind of working too. I started off with a table, and then I was gonna make the graph by hand too. So let's see what we've got here. So here's a hint. You can ask the kids, can you organize the information in a different way? Are there any trends that you notice? So task A probably would lend itself to an equation. If the students could write it, maybe, it depends on where they are. And then task B would be nice to look at in a table. It just depends on where your students are at. So let's look at, if we were to respond to task B, what we could do. Task B is actually a growth that is weekly, and then task A is a growth that's daily. So that's the main difference between the two tasks. But one thing you can do, and I'm just gonna click on to a visual here. I took and typed all the weeks out in a Google Sheet, and then I typed all of the data from the cases that was from the tweet, and then I just pretty much did a dot plot here. And so that's not something way out the box that your students couldn't do, and you can see how the growth looks very similar to an exponential curve. So that's one representation. I would hope that most students would think to put the information in a table, but maybe not. Students can describe the rate of growth in some kind of way, or they can use the equation. So if they were to use the rule, in task 1 in particular, what they could do is pretty much write the rule. And I pretty much clipped this screen from Desmos, and I'll show you how you can do that. But basically the rate was 30% daily, and it was exponential growth. And so I could write my rule easily here, but I would have to know that was the rule that I was writing. And then I could plug in the value for 30 days here, and then I would get this number of cases in 30 days using this particular model. So those are a couple of solutions. Or we can go directly to Desmos and look there. So what you can do here is regression. So I'm gonna do this along with you guys, because you could take this data directly from that tweet and do an exponential regression in Desmos, and your students can do this. And so I want to walk you through those steps if you guys are ready. Are we ready? Can you all give me a thumbs up? I'm not sure.
So Leah, you want me to, so I'm going to minimize my screen.
Mm-hmm.
And I'm going to click on my, open a new browser, and I'm going to go to Desmos.
Yes.
Okay, I'm going to do that. All right, I'm in, and I'm going to start graphing, right?
Yes.
Yeah, it's just that easy. Oh, wow, it really was just that easy. All right, fabulous.
Okay, so from here, we are going to click on this plus box here. We're doing task B now. And click on table. And so from here, you should have something that looks like this. And we're going to take the information from that tweet that was in that New York Times article, and we're going to put it directly into Desmos. So there was 9 weeks So I'm putting this information in. If you want to follow along with me, you can. And so I know this is just progression here. And I'm taking this directly from the article. And so that's what I thought was pretty neat, that I could use that context and pull math right out of it. And so you're hoping that as your students are looking at this growth, they're able to describe it in some sort of way other than it grows really fast. Although that's true, you know, it's that making sense and being precise that we are wanting our students to be able to develop that language to describe the math. So, wait a minute, did I skip one? 14, 25, 125. Okay, I'm just checking my data here. Okay, so from here, I can go over to the next line and
You skipped 59.
did I skip one?
Yeah, it should have been week 6, 25.
Okay.
Week 7, 59.
I thought I was missing one.
Week 8, 125.
Nice.
And then
Thanks.
week 9, 1004.
Nice. Appreciate it. Thanks. All right, so now I have this table in decimal. So far, can you see what's happening? Do you think your kids will be able? I think kids will be able to do this. And you can also like save and share a graph. So once you do this and your students can do this, they can share it with you. All right, so we go to line 2 and it'll do this regression, and this is where it gets a little tricky, but not so much. So we're gonna press a Y1, whoops, not YX, Y1, and you can use your keyboard for this, right? And then we're going to use, it looks like a squiggly, it's like a tilde. So that's what gives us that symbol there, letter A, B. And as you see, it's already doing the statistics for us. And so if I click on this key here, it'll give me that exponent I need, and I'll put X1. So now I have calculated using decimals an exponential model with pretty good fit that shows the growth over time. And so you can zoom in and out. It doesn't look like it's very close because none of the points are actually on the curve, but according to the regression statistic, it's pretty close. But that obviously a regression isn't the learning target per se, but there is a way to model this growth, and that's a really cool way if you wanted to demonstrate that for your students. And then if you wanted to take it further, you can look at this, the absolute value of this distance and see how close your fit is and talk about that as well. And so I kind of already did one. I'm switching back here and I labeled the axis. And like I was saying, if you wanted your students to graph in decimals, they can share a graph with whomever. It will allow you to get a link that you can import and embed. And so if there's an assignment that you ask your students to do, they can do that and import or embed that image so that they can get credit. Questions so far? Questions about how to do an exponential regression with decimals?
Yeah, Abby has a quick question. Abby, unmute and ask her your question because she can.
Yes.
No, I was just asking if this is essentially the same thing as doing the same types of functions on a TI, but of course, them being able to use decimals.
Yes, absolutely the exact same. And you could probably look at the syntax and see it's not much different. So for a linear regression, right, you would just put it like in the y equals mx plus b form, and it'll let you do a linear regression also in decimals. But it's a way for our kids to do this without the calculator. Actually, when I was planning this session, I was like, oh snap, I don't have my calculator. I guess I'm gonna have to go and get one. But I was like, you know what? I can use decimals because my kids are probably not gonna have, or our kids aren't gonna have access either. So that's just something to consider. But it's the same thing as with the graphing calculator. To me,
Here's what I know. Desmos, Leah, is that it's as intuitive as what they're used to on their graphing calculator. There's a little more power in the Desmos product, but then it's just as intuitive, and so kids will be able to click, click, click there through it. And Desmos ends up being, it's the platform for a lot of the interactive online high school math stuff. Desmos just has the platform that's so vibrant.
All right. Okay, so there are 2 more tasks that we obviously are running out of time, but here's the second task. So this visual also is from the New York Times article, and Britta Jewell was the person who came up with this idea of let's make some changes now to prevent the spread for later. And so I thought this was an excellent visual you can give to kids and just ask them what they notice and wonder what are the parameters. So that would get them, once again, developing that conceptual understanding of growth rate. And then asking them to describe rates that could represent the growth in each of these colored regions. And so the idea is that if we could avert one case now, that will slow our growth later. And so that's really why we are in this social distancing, right? So this was the powerful data that was needed to convey our leaders that we needed to spread out to stop this, well, not spread out, but distance ourselves to keep this disease from spreading. And so you could ask the students, what's the difference in these growth rates and what can we do as individuals to make this change happen? So what do you guys think about that in reference to how students respond and what type of answers you would get from them given this visual? You can just share out. Do you think this would be something that students would be able to talk to you about? If you gave them this visual in an assignment, would they be able to respond and say, hey, it kind of looks like an exponential curve. It kind of looks like it's growing fast. It's just some things to consider. And you can also look at those growth rates and compare them. And students can also graph and do graphs in Desmos to compare rates. I'll move on because we are, time. So some things that students could do, I just snipped a picture from Desmos of some different graphs that I could make with different rates. And you could do that as well with your students or have your students do those. And then there's another task here that I pulled from the same article that you could do some of the same things. What are some possible R values that can model the growth? Explain how you made your decision, check your work in Desmos. And so you can have students consider the growth in other countries as well as the growth in Louisville, the growth in Kentucky, the growth in their neighborhood, and some things they could do to flatten out this curve. Sorry, I gave myself a timer on. So that would be task 3, and these are all in the PowerPoint. I'm gonna move along for sake of time. So if you really wanted to dig in more in this PowerPoint, I've added a Desmos activity. It's called Match My Exponential. You've probably seen it. You can assign it to your class of students, and they pretty much go through a series of questions where they need to match the graph to the equation, and it's interactive amongst each other, and you pretty much would assign a class code to them and they can work on that. There's also some simulations used in Java Lab, which I think are pretty cool for high school. And there's also, if you are interested in any of the references that I use in today's presentation, I put those in an extension as well, and you can access all of those links and resources. There's also virtual manipulatives. Obviously Desmos, which we were looking at today. There's PhET interactive simulations that are really great for science and math. GeoGebra, and there's also that DIDX math virtual manipulatives that are really great. If you tune in with me again a week or so later, I'll be doing some sessions with PhET interactive simulations and GeoGebra. So if you are interested, you can join me then. As always, KCM is here for teachers and to support your work during this time. And we're here for you guys. So I hope you feel that way. And air hugs to everyone. Thank you for participating in today's session. If you want to hang out a little longer and ask questions afterwards, I'll be here a couple minutes to do that. Please give me your feedback and share. And thank you so much for attending.
So one of the things we always like to do as we're ending our sessions is to give the presenter some shout outs. So if you could unmute your mic and tell Leah a little bit about what did you love about her presentation today?
And as always, there's our information to our website. Please check it out. We have tons of resources available for you. And we are here for Kentucky's teachers and beyond.
This is exactly what my PLC mates and I were talking about wanting to do while we're doing this digital learning. So thank you. This is perfect.
Thanks, Liz. Thanks for joining in.
Hi, this is Desiree.
Hey,
I want to
Desiree.
say, hi, I love the video. I think anything hands-on, like anything that actually shows the students what you're talking about is perfect. And I think that you used a lot of those for me in high school, and I think you're going to continue to do that. So I think it's great, and I think it helps a lot of kids. Although not everyone's like a visual learner, that is one of the most like easiest ways I feel like for kids to kind of comprehend what you're trying to get across. So I love that.
Thanks, Desiree. Thanks for joining.
No problem.
Anyone else? Any other shares, chats?
So one thing that I do want to tell you is that Leah is having a session every Thursday. And so every Thursday at 1 o'clock, you can log in. Leah, remind me, what's next week?
Okay, so next week I will be looking at geometry. And so I will be doing some activities with GeoGebra online, which is also free. So looking forward to it. You all could join me. It'll be
That'd
great.
be great. Abby from Owensboro will be there. Geometry is her jam. More importantly, Abby, be sure to be ready to share your good ideas, because
Yes.
she's got that. She's got some superpowers when it comes to geometry. So we want to thank you so much for joining us. We want to thank Leah for the time and the effort that she very thoughtfully put together this presentation, with it being so relevant. And I felt like this was some of the math that made me smarter today. So I thank you, Leah.
You're welcome.
All right,
Thanks,
see you
guys.
guys.